The video demonstrates how an overall collective is determined by duplicating a single project for different loads. We will briefly go through the single project serving as the basis, which has two load cases. Now let's look at the defined SN curve. Next, we go to the load menu, where two load time functions are entered. We can see these two load functions acting in parallel in graphical form. The corresponding unit loads for these load functions are defined in the FE menu. Let's briefly display the parameter settings. We'll go through these quickly. Very standard settings have been selected here. It is important that the individual project can be calculated. You can verify this by displaying the damage sum. Now comes the actual task, creating the container project. To do this, the WinLife user must first define a file in which the paths to the load data are specified. Next, the desired frequency of this load data must be specified in the target time column. A number is also required to indicate the column number of the time channel. Based on the target time entered here and the total measurement duration of the load files, WinLife calculates a multiplier for extrapolating the damage values. Let us examine this procedure in detail. The first subproject is described by the load file loads 0102. The total measurement duration is 655.342 seconds, as shown in column 1. Because the target time in this case is 10 times as long, a factor of 10 is used to scale the total damage from the measurement. We now go to the File menu and select Change to Container Project. We select the multi-load file we are familiar with. This integrates the defined load sequences into the project. The load sequences can now be viewed in tabular form, as shown here for partial load 1. The structure is the same for the other partial loads. Only the load file is swapped for the other partial loads. And, of course, the load sequences can also be displayed graphically, as shown here for load sequence number 5. We can see the two loads. The fatigue life calculation is now carried out. This may take a few seconds. The service life has now been calculated. The nodes, the total damage and the associated section planes are displayed. As you can now see, individual projects have been created. In this case, there are 8 of them for the individual load datasets. You can now open the projects and view and edit them in the usual way. For example, you can display the total damage for the first subproject. The log is now of particular interest, as it provides a detailed breakdown of the calculation process. Here, you will also find the multiplier we discussed earlier. This was derived from the desired time and the measurement duration. This multiplier can also be found in the load menu. For the first subproject, let's display the rainflow matrix. Now let's return to the container project and determine the total load collective and the service factor for the total load collective. In our case, the service factor is approximately 3.199. This means that if you multiply the load collective by this value, you obtain the damage sum for a failure. It is also possible to display the SN curve with load or the rainflow matrix. If the container project is to be reverted to the original standard project, the following command is used. This concludes the example, and thank you for your attention.